Hi students, how are you all? I think everybody are good. Those who are listening all these video classes can feel mathematics easy and you can easily understand the procedures of the problems and you can easily learn the concepts. I hope it will help to you to get good grades. So follow the classes well, listen them without lagging, without wasting your time, very clearly like in your class how an experienced teacher will explain. In that way only I am explaining here. So listen the classes well with full of interest, you practice them. So when you practice them after listening the classes, then only you will get perfect in mathematics. Please remember that one. So as you are following the classes today, in this video class we are going to discuss about one of the statistical concept. That one is the last concept of this chapter, which is called as graphical representation of cumulative frequency distribution. Okay, right. So today we are going to discuss about graphical representation of cumulative frequency distribution. Okay, right. So according to statistics in our syllabus, cumulative frequencies are two types for us. One is LCF, another one is GCF. That means less than type cumulative frequency, another one greater than type cumulative frequency, that is GCF. Okay, so we are going to know about their distributions graphical representation. Okay, cumulative frequencies are two types, LCF or GCF. That means less than type or greater than type. We can also see sometimes it is also called as more than type. Since cumulative frequency is two types, we can convert them graphically in two models. Okay, so graphical representation of cumulative frequencies will be in two models. Those are called LCF curve. Another one is GCF curve. Okay, right. These are the two types of graphical representations. Okay, these two LCF curve, GCF curves together called as ogive curves. They together called as ogive curve. Spelling is OZIVE. It is read as ogive curves. Okay. So today we are going to discuss about ogive curves. Ogive curves are two types: LCF ogive curve or GCF ogive curve. That means less than type cumulative frequency curve or more than type cumulative frequency curve. Clear, Nana? Right, two types. How to draw them? Simple thing, Nana. While we are going to represent anything in graph, we need to represent according to x-axis and y-axis. So together their representation will give us a point. Understood? So graphical representation is mainly based upon points. So here also we need to convert the total statistical data in this cumulative frequency distribution into points. Okay, so how to get the points? As I told you before, representation should be with respect to x-axis, so x coordinate, y-axis gives you y coordinate. So x coordinate, y coordinate together gives us points. But how they will come? Listen, under this LCF curve on x-axis, this is important point, Nana. On x-axis we will take the upper boundaries of the class intervals. Please remember this one carefully. As well as on y-axis we will take LCF values, less than cumulative frequency values. What is meant by LCF value? So its name is less than cumulative frequency, means the cumulative frequency starts with least value, gradually increases and reaches to highest value. So LCF means it is an ascending order, starts from least value to get highest value in the table from top to bottom. least value cumulative frequency starts, gradually it increases and reaches to the total frequency, that is LCF. That LCF will be taken on y-axis and upper boundaries of the class intervals will be taken on x-axis. Got it? Together they gives us points, plot them in the Cartesian system and join them with a smooth curve to get the required LCF curve, which is also called as ogive curve. Understood? Another type, that is greater than cumulative frequency curve or more than type ogive curve. For this, what we have to do, on x-axis, this is important for this, on x-axis we will take lower boundaries of the class intervals, lower boundaries of the class intervals on x-axis, and on y-axis, we will take GCF value, greater cumulative frequency value, greater cumulative frequency. Means what? The cumulative frequency in the table starts with highest value, means total frequency will become first cumulative frequency, that is greatest value is the beginning value, and gradually it decreases and reaches to the least value. So GCF cumulative frequency means starts with highest value, that is total frequency, gradually decreases, reaches to least value. That's why it represents decreasing order, descending order. Understood? So graphs will also be look like that. In the descending order, its graphical representation will be there for the GCF value. Coming to the previous one, LCF ogive curves, the curve will comes in the increasing order type, upward direction. Understood? These are important for bits. Okay, ma? After knowing the introduction and the theory of ogive curves, we are going to do few problems, important model problems from exercise 14.3. Sorry, exercise 14.4. Those are first and third. These are for drawing ogive curves. Important model problems from last exercise 14.4. Okay, so the first question, having some data with this cumulative frequency distribution table, that one is class intervals they had given from 250 to 300, 300 to 350, 350 to 400 and like that, and their frequencies like this, and they are asking to draw the less than type cumulative frequency distribution curve. Means they are asking LCF ogive curve. Okay, right. As I told you before, how to do that process to convert it into graphical representation. Okay, Nana? It is very simple process, but very important for public examination models. Okay, how to solve, how to do, let us observe this one. Listen to me carefully. As I told you before, for the less than type ogive curve, for the less than type ogive curve, prepare the table like this. Okay, na? What is the table we need? As I told you before, we need to take upper boundaries on the x-axis, so that will become first column. Okay, then LCF value will be on y-axis, so second column will be LCF. Okay, right. How to prepare? From the table, check whether it is continuous or not. If the class intervals are continuous, then the class interval lower limit is called as lower boundary, upper limit is called as upper boundary. Okay, if the class intervals are not continuous, we cannot call them directly as boundaries. Okay, make them into continuous and then they will become boundaries. So here the class intervals are 250 to 300. Next one starts with same 300 to 350 and starts with same 400, starts with same. So continuity is there. That's why all the lower limits or upper limits are called as lower boundaries and upper boundaries. Keep that one in mind. Then the upper boundaries will become 300, 350, 400, 450, 500. Understood? they will comes on the x-axis. But how to write it? We need to write like this: less than, what is the first upper boundary? 300. Less than 300. Next one, less than 350. Next one, same way, less than 400. Next one, less than 450. Next one, last one, less than 500. Okay na? This is the formality to prepare the table, but our main thing will be focused on the numerical values. Okay na? So that's why this is called less than type ogive curve. So now how to prepare the LCF values? I told you already, LCF means least value to highest value, ascending order. How it will comes? First value first. Remember that word. First value first. This is the just hint, shortcut to remember. That's why it is 12. Next one, 12 plus 14, 26, plus 8, 34, plus 6, 40, plus 10, 50. So like that, the cumulative frequency starts with least value, which is first value, and gradually increases and reaches to the highest value, which becomes total frequency of the data. Understood? So this gives you ascending order. That's it. This table is enough. From this table we will get therefore required points to plot. Plot, what is the first point, Nana? Ordered pair 300 comma 12. Understood? This one is a pair, x value y value together. Okay, comma, next one ordered pair 350 comma 26 comma 400 comma 34, and the next point 450 comma 40, and last one 500 comma 50. These are the 5 points required to plot. Okay, how to plot them? So now these values has to be converted into graphical representation in the Cartesian system. For that we will take x-axis and y-axis together. This one is x-axis and this will become y-axis. Okay, Nana? So now automatically this is the origin for them. Got it? This is the Cartesian system. In the graph, in our regular graphs, what we are using, they will be partitioned with 1 centimeter, but how much is that 1 centimeter will be varied from cosine to cosine. So that's why how much is that 1 centimeter has to be written as a scale in the graph. Understood, Nana? So I will explain that one clearly. In the graph they will be partitioned with 1 centimeter. So like this, Nana, like this. Okay, here also with 1 centimeter, here also with 1 centimeter graph. Roughly I am drawing here with 1 centimeter equal partitions. So this is the Cartesian system with x-axis and y-axis base as origin. But how much is that 1 centimeter? So that has to be written as a scale. So scale is compulsory. On x-axis 1 centimeter equal to how much? On y-axis 1 centimeter of the graph equal to how much? That one we need to write. That will be depends upon the data or numerical values of the question and varies from question to question, problem to problem. Okay, so now observe that one, and as your wish you try to take the partition or scale. Here the x values are increased by 50 50 50 like that. So and starts with 300 here, upper boundaries. Okay, so keep it in mind. That gives us x-axis representation, scale value. And here LCF starts from 12, 26, 34, 40, 50, 50 only. So I am taking x-axis 1 centimeter as 50 units. 50 units. Got it? Next, on y-axis, I'm taking 1 centimeter as 10 units for my convenience. So that scale will be varied from question to question. So logically, we need to think about the numerical values. We should write it properly. Now mention them. Then automatically x-axis will be having 1 centimeter equal to 50 units. Then it will become 50, 100, 150, 200, 250, 300, 350, like that they will increase. But we started with 300 only for this table. Okay, so up to 300, all that graphical part will be waste for us. Understood? So since our values are upper boundaries are starts with 300, so we need to take the first value as 300 for our convenience. Next one will become 350. Got it? Increased by 50 50. But after the origin according to scale, it will come 50, 100, 150. 50, 100, 150, 200, 250, then 300 will come. Whatever that gap is there, 0 to 300, that gap is unnecessary for us. That's why cut it and link it. Cut and link. That is called as kink. That is called as kink. That's why whatever the values are there, unnecessary values, those are cut and linked here. So that part is merged. Okay, so then after the origin using kink, we have taken our required first upper boundary 300. Got it, Nana? Very clearly explained it. Unnecessary values of the class interval upper boundaries are cut and linked to make the graph very clearly. That's why we used kink. This is the symbol. It should be done in the first centimeter part only. Understood? That's why this will become 300. Next 350. Next 400, 450, 500. Those are the values. That is enough. Coming to y-axis, it's not a problem. Kink will not comes on y-axis according to our syllabus. So here on y-axis 1 centimeter partition will be equal to 10 units. That's why this is 10, 20, 30, 40, 50, 60, like that, but up to 40 only we will reach. Now plot the points properly. Understood? So what is the first point? Ordered pair 300 comma 12. What is the logic and correct process to plot the point? For every point you start from origin. Consider the two values together to reach the destination. So okay, from origin, first value 300, from there 12 together. Don't put points for one singular value. It is a pair. Pair means both the values has to be considered to reach the destination. So from origin 300 comma 12 means above the 10, second millimeter will be there, second partition. This is representing 300 comma 12. Plot the point, write the coordinates immediately. That is compulsory. Next one, ordered pair 350 comma 26. From origin 350 and 26 means from 20 next sixth thin line. Okay, right. This gives you ordered pair 350 comma 26. Next third one, ordered pair 400 comma 34. From origin 400 and 34 means above this 30, the fourth one, this is called ordered pair 400 comma 34. Next one, ordered pair 450 comma 40. From origin 450 and 40, exactly opposite to this 40. This is 450 comma 40. Plot the point, immediately write the coordinates. And the last one is ordered pair 500 comma 50. From origin 500 and then 50 means opposite to this 50. This is 500 comma 50. Understood? So now listen, the LCF values are ascending order, least value to highest value. That's why automatically the points are coming in the ascending order, join them with smooth curve, to get our required LCF ogive curve. Understood, Nana? Curve. This one. Okay. Now, after joining them, once again, you highlight the points for our clarity. Understood? This is required less than cumulative frequency distribution ogive curve. That's it, Nana. For this, they will give you either 4 marks or 6 marks according to the question. Got it? Right. But sometimes in the examination, from the graph, they will ask you to find the median. But for that, how to conclude this one? After plotting, join them with smooth curve to get LCF ogive curve. Nana, this is the conclusion of the problem, right? From this, how to find out median? Therefore, if they ask to find the median, how to find out? What is the total frequency here? N value. N equal to how much, Nana? Here N equal to 50. Got it? Then middlemost value N by 2 is equal to 50 by 2, that is equal to 25. Got it? So in the proper arrangement, ascending order already we are observing, na? The middlemost value gives us median. So N value 50, N by 2 25. That's why upon this y-axis, which is LCF here, upper boundary is on the x-axis. Okay, at exactly 25, N by 2 value 25, okay, you draw the horizontal line which is parallel to x-axis. It cuts the curve at a point. Okay, Nana? So now it is beyond this 350. Okay, so now get it on x-axis. Okay, parallel to y-axis. It touches the x value, that gives you the median. Understood? Find out the N by 2 value. Take that N by 2 value on the y-axis, draw a line parallel to x-axis. It cuts the curve at a point. From there, draw a vertical line downwards upon the x-axis. It touches the x-axis. That x value gives you the median. It is approximately 340. Okay. If you draw it on the graph paper, you will get accurate median value. Okay, na? In rare conditions only they will ask you to find out the median. So then you need to apply N and N by 2 value and joining these parallel to x-axis, parallel to y-axis and the median. So it is approximately 340 for this question. Got it, Nana? I think you understood it. Okay, ma. Now we are going to take one more model problem of this concept, that is third problem of this exercise. So what they are doing, they had given one grouped frequency distribution table with class intervals and frequencies, and they are asking change the distribution to more than type and draw its ogive. Means they are asking to draw GCF ogive curve, which is also called as greater than type ogive curve or more than type ogive curve. So for this, what we have to do? Process is simple and easy. On x-axis we need to take lower boundaries, and on y-axis we need to take GCF value, greater cumulative frequency. Okay, how to prepare the table? Just observe this. The solution will be for GCF ogive curve. For GCF ogive curve, the required table will be there like this, with two columns, two simple columns, one based upon lower boundaries and the second one will be based upon GCF value. One gives x coordinate, another one gives respective corresponding y coordinates. So how to prepare the table? Here we need to use this word. What kind of ogive we are going to draw, that word we need to use. So more than type means, that's why we are taking lower values. If the representation is lower value, remaining things will be more than that one only. That's why we use this word more than. What is the first lower boundary? 50. Because class intervals are continuous. That's why directly the least value will become lower boundary. So using the lower boundaries, prepare the table with the word more than first lower boundary. Next one, more than second lower boundary 55. Next one, more than 60, more than 65. Gradually they are increased by 555. Observe that one while writing itself. So more than 70, and last lower boundary 75. That's why this will become more than 75. So now this is the table we require. Okay, right. So these values gives us x coordinates of our required points to plot. What are the GCF values? GCF means total frequency of the data will become first value. Starts with greatest value, which is nothing but total frequency. What is that? 2 plus 8 10, plus 12 22, plus 24 46, plus 34 46 plus 38, this is 14, that is 84, plus 16 will become 100. What is the total frequency here? 100. That is the greatest cumulative frequency. Next one, from this total frequency, greatest frequency, subtract the first individual frequency. 100 minus 2, that will become 98. From this, subtract the second one, 98 minus 8. Understood the logic? That is 90. This minus third value, 90 minus 12, that is 78. This minus next value, 78 minus 24, that is 4 and 5, 54. 54 minus next value, 38, that will become 16. Understood? So last value will become last frequency. So if both are matched, our calculation table is correct. Otherwise there will be a mistake. Okay, Nana? Here logic is last value is last. Last value is last one. So in the previous table, first value is first. In this table, last value is last. Understood, Nana? Then the table is correct. Right. What are the points? Plot. What is the first point, Nana? Ordered pair 50 comma 100. Next one 55 comma 98. Next one ordered pair 60 comma 90. Next one ordered pair 65 comma 78. Next one ordered pair 70 comma 54. Next one ordered pair, last one 75 comma 16. Understood? Right. Here you observe that for this more than type, the values are starts with cumulative frequency GCF starts with highest value, gradually decreasing means it is descending order. Okay, Nana? Descending order. Automatically graph will be descending form. Okay, keep it in mind. How to get it? Draw the x-axis neatly and a y-axis respectively. Their origin is here 0 comma 0, and they will be partitioned with 1 centimeter in the graph paper. Okay, on the x-axis, and on the y-axis also they partitioned equally with 1 centimeter upon the y-axis. Okay, back side also same, but how much this 1 centimeter is along y-axis, along x-axis we need to observe. So that will be returned using scale. That's why on x-axis that 1 centimeter of the graph paper equal to how much, and on y-axis that 1 centimeter of the graph paper equal to how much. Both we need to write. So according to the table only you can guess. Now lower boundaries are increased by 555, starts with 50. So easily we can guess on x-axis 1 centimeter equal to 5 units. Got it, Nana? Right. Now these are starts from 100 and up to 16. That's why on y-axis I am going to take 1 centimeter equal to 10 units for my convenience, for our convenience, for our convenience. Okay, Nana? Right. Now plot these points properly according to this. If on x-axis 1 centimeter equal to 5, then this will become 5, 10, 15, 20, and so on. Somewhere else it will become 50. Next 55, 60, 65, 70, 75 will come. From x value 0 up to required value 50, this total graph paper graphical Cartesian system is waste for us. That's why to utilize it properly, cut it and link it. That is called as kink. Already I told you. I used kink. Understood, Nana? Using kink, we can eliminate the unnecessary part and starts with our required value. In the points or in the table, it will be there. That is 50. Next one 55, 60, 65, 70, 75. That's it. Those are the values. Upon y-axis, 1 centimeter equal to 10 units. That's why it is 10, 20, 30, 40, 50, 60, 70, 80, 90, and extend it according to our requirement. This is 100 on y-axis. Got it, Nana? Right. Now, plot these points properly. Already in the previous problem explained. Every point plotting should start from origin. Consider two values, x coordinate to y coordinate together to reach the destination of the point. Okay. Ordered pair 50 comma 100. Origin 50 comma 100. This one. This is ordered pair 50 comma 100. Plot the point correctly and write the coordinates. To you in your graph paper it comes very neatly, very easily. Next one, ordered pair 55 comma 98. Ordered pair 55 comma 98. Little less than that. This is 55 comma 98 together from origin. Next one 60 comma 90. This is 60 comma 90. Little less than that. This is ordered pair 60 comma 90. Next one 65 comma 78. 65 comma 78. Under this 65 comma 78 means under 80. Under this 80, the second small line, that is 65 comma 78. Got it? Next one 70 comma 54. Ordered pair 70 comma 54. 50 is here. Above that the fourth thin line. This is 70 comma 54 ordered pair point. Last one ordered pair 75 comma 16. 75 comma 16. 16 is under this 16 means under this 20. Okay, Nana? Right. This is ordered pair 75 comma 16. That's it. Now you see the plotting of the points. They are starts with peak value and gradually decreasing. That's why descending order. Okay. So now join them with smooth curve. Join them with smooth curve. This gives us GCF ogive curve. Understood, Nana? This is our required curve. Right. Now highlight the points once again with a pencil after the plotting to identify them easily. Understood, Nana? Graph completed, but write it. Join them with smooth curve. to get GCF OZIV. Understand? That's it. Graphical representation problem is over. If they extended find the median from the graph, then only we need to take what is n value here, total frequency 100, that implies n by 2 value, middlemost value 100 by 2, that is equal to 50. Got it? Right. Now in this proper order, descending order, where will be this middle value? So middlemost value of the proper arrangement gives us median. So that gives us median. Okay. What is this 50th observation means? In this GCF, y-axis, take n by 2 value, middlemost value 50. It is here. N by 2 value. N by 2 value 50 is here. Draw a line parallel to x-axis. This is the direction. To touch the curve at a point. Understood? From there, draw a line parallel to y-axis upon to x-axis. You will get an intersecting point. Its x-coordinate is the median. That's why here it is 72 approximately. Therefore, median is equal to 72. Observe the direction. Find out the n value. Gives you n by 2 middle value, middlemost value of the proper arrangement data, gives you a line parallel to x-axis. It cuts the curve at somewhere. From there, try to draw a point upon the x-axis. It intersects the x-axis. That x-coordinate is the median. Understood? Okay. In your graph paper, if you draw it properly according to my words, you will get exact median to the question. Right? Here, roughly I got median 72. It may be 71 or 73 according to you. You observe that one clearly. Okay, Nana? Right. So these are the procedures. For any frequency distribution table, you can draw the OG curves by converting them into less than type model or more than type model using their respective points. From the graph you can find out the median also. Understood? Sometimes for 2 marks they will give you normal grouped frequency table. They will ask you just its more than type table. From the normal table to more than type table only they will ask you to prepare. So prepare this table only, enough, you will get 2 marks. Same way they will ask you to prepare less than type cumulative frequency distribution table from the grouped frequency table. So how we prepared a table in the previous question, in that way you just prepare the table, you will get 2 marks, enough. So those kind of problems also important for us. Okay, practice all the problems perfectly, go through additional problems to get excel in your application skills. All the best. Thank you.